Every breach looks different. The reason behind them is always the same. By now, the pattern is clear. Systems fail not because attackers are unstoppable, but because the same assumptions are rebuilt over and over again. Different technology, different decade, same logic. After every major breach, the response follows a familiar script. Investigations begin. New tools are deployed. Policies are updated. Lessons are written down. And then the system moves on. What rarely changes is how systems are designed in the first place. They are still built for efficiency, for speed, for scale. Security is layered on, later once the system already exists. This is not negligence, it's incentive. Organizations are rewarded for growth, not restraint. For launching quickly, not cautiously. Security slows things down, and anything that slows progress is treated as optional. As systems grow more complex, they rely more heavily on abstraction. Layers of software, layers of automation, layers of trust. Each layer assumes the one below it is working correctly. When something fails deep inside that stack, detection becomes difficult. Responsibility becomes blurred. No single person understands the entire system anymore. This is where hacking becomes inevitable, not because of malicious intent, but because complexity creates blind spots. And blind spots invite exploration. Groups like Anonymous demonstrated this in a different way. They didn't rely on a central leader or advanced infrastructure. They relied on loose coordination and shared intent. The system struggled to respond because there was nothing solid to confront. Others, like Julian Assange, exposed a different weakness. Once information exists inside a system, controlling it becomes almost impossible. Access scales faster than authority. These cases weren't identical. Their motivations were different. Their methods varied, but they all revealed the same flaw. Systems assume control where control doesn't fully exist. Modern technology hasn't fixed this. Cloud platforms still misconfigure storage. AI systems still inherit biased or unchecked inputs. Automation still trusts upstream data without questioning its origin. The interfaces look new. The language has changed. But the structure underneath is familiar. Trust is still assumed. Verification still lags behind. Security frameworks improve. Detection tools evolve. But they are always responding to yesterday's problem. The next system is already being built with the same priorities as the last one. This is why hacking never disappears. It adapts. It follows systems as they grow. It lives in the gaps between design and reality. The uncomfortable truth is that perfect security is incompatible with scale. The larger a system becomes, the more it must rely on trust, and the more fragile it becomes. Hacking, in this sense, is not an anomaly. It is feedback, a signal that assumptions were made too early and questioned too late. Every generation believes its technology is different enough to escape old mistakes. And every generation learns eventually that it isn't. This series wasn't about teaching hacking. It was about understanding systems. Because systems don't fail randomly. They fail predictably. And until systems are designed with that reality in mind, the pattern will continue, quietly, consistently, invisibly. Not because systems are broken, but because they are working exactly as they were designed to work. Hacking doesn't end. It waits for the next system to forget.